Hi, my name is Isaac, and for my project, I determined the concentration of glutamate in proteins. My mentor for this project was my mom, Catherine Mitchell, and the reason why I chose to do this project was actually because of my mom. Uh, my mom suffers from psoriatic arthritis, which is painful and swells many of her joints, and but so does 350 million people around the world who also suffer from this disease. And after years of trying to figure out what causes my mom to swell up so inconsistently, uh, somebody's oh, okay. And the reason why I'm doing this is because my mom, and after trying to figure out what causes my mom to swell up so inconsistently, she stumbled upon a research paper linking glutamate to the production of an inflammatory cytokine called TNF alpha. So what is glutamate? Glutamate, also known as glutamic acid, is the is a most common and naturally occurring amino acid and is produced through fermentation, aging, ripening, and the cooking processes. Glutamate is found in all foods, which is a problem, and that's why people with arthritis are struggling from finding things to eat. And so foods high in glutamate are aged cheeses such as Parmesan, soups and broths, which have been cooked for and heated for long periods of time, ripened fruits and vegetables, as well as packaged in anything with monosodium glutamate, also known as MSG in them. Uh, Glutamate or many people suffering from arthritis struggle eating foods high in glutamate because it has found to cause inflammation due to the increase in the production of an inflammatory cytokine, TNF alpha. Elevations of this particular cytokine within humans is believed to stimulate the production of other chemokines, which results in an increase of inflammatory cells within the arthritic joint space. So because many people are unaware of what foods may contain high levels of glutamate, as well as how the preparation of the food, such as heating or cooking, may change the levels of the amino acid, people who suffer from arthritis may be unintentionally hurting themselves even more. The purpose of this project was by using a UV-vis spectrophotometer to determine the concentrations of glutamate in beef, chicken, pork, turkey, and cod after cooking in a slow cooker. Because glutamate naturally produces through the cooking processes for my project, we wanted to determine the concentration of these five common proteins used in everyday meals after cooking them for extended periods of time. The concentration of glutamate was determined in their own trials. First, we cook the protein, collect the samples, and then we send it to the lab to be prepped for analysis, then plugged into the absorbance calculator that gives us the concentration of glutamate per sample. So to start, each protein was placed in a slow cooker with water to prevent it from burning, as well as the lid on to retain any moisture, where it was then cooked for around 80 to 90 degrees Celsius. This was chosen to best replicate cooking the proteins for long periods of time, such as stews, broths, soups, roasts, etc. Samples of the liquids would be taken at 120, 240, and 720 minutes, which is equivalent to 2 hours, 4 hours, and 12 hours. After collecting the samples, they were refrigerated and then taken to the lab where it was immediately prepped for analysis. So once at the lab, prior to any food samples being run, both a standard and a blank must be run to ensure accuracy within the procedure and our data sampling. A sample that has been spiked with glutamate was analyzed by the spectrophotometer in order to validate our method, as well as a blank sample, which contained only water, and that acted as the blank. But after both the blank and the spike have been run, then food sample testing can then take place. We first centrifuge and filter each sample. Filter each sample, and then the sample along with the solutions from the glutamate assay kit provided by Megazyme were added into a sterile glass cuvette, where it was then placed inside the spectrophotometer to be analyzed. The glutamic acid concentration in each sample was determined by our spectrophotometer, the Shimizu 1900i UV-vis spectrophotometer. And the function of this machine is to identify and quantify substances by detecting ultraviolet and visible light being passed through reflected samples. Glutamate is absorbed at 492 nanometers, Therefore, the quantitative technique was used to measure the concentration of the chemical substances that absorb the light at every time interval for each protein to determine the amount of glutamate within each sample. So to analyze the data, a data table linked to the spectrophotometer was used to record the absorbance of the samples. For each protein, we took 3 samples at 2 hours, 4 hours, and 12 hours. And each sample per time interval was run twice to ensure accuracy in our results. After a total of 4 minutes of being analyzed, another light-sensitive solution was added into the cuvette, where it was then mixed and placed back into the spectrophotometer to be read. The absorbance again for an elapsed 20 minutes. After recording the absorbance of all the samples, the data was then placed into the MegaCalc glutamate concentration calculator, where the difference of the data before and after adding the light sensitive solution was calculated to determine the amount of glutamate within each sample. So by looking at these graphs, we can see that beef, chicken, pork, and turkey all showed an increase in glutamate concentrations from 120 to 720 minutes. And yeah, we can see how like close beef, pork, and turkey's data is to each other. But the one that stands out the most is chicken. And this is because chicken has an enzyme called aspartyl aminopeptidase, which is an enzyme in chicken, which is shown to increase the amount of glutamate during the cooking processes, which is why it's almost four times bigger than the beef, pork, and turkey concentrations at 12 hours. Unfortunately, the cod results were inconclusive due to there being not enough water, fat, and moisture in the cod, as well as in the slow cooker itself. So the longer the cod was cooked for, there wasn't enough water left in the pot, so it started to burn it and like disintegrate the sample. So that was unfortunate. But when you look at the data from 120 to 240 minutes, there's shown to be an increase in the concentration, which would prove that the longer the protein is cooked for, the longer the protein is cooked for, the higher the concentration of the sample. And this is a graph showing all 5 of the proteins. So the green is the chicken, and that you can see how like drastically different it is. And then the yellow, the blue, and the gray are very similar, and that's in the middle. And the red is the cod. What we can conclude from my experiment is when beef, chicken, pork, and turkey are cooked for longer periods of time, they all show an increase in the concentration of glutamate, but especially within chicken. People suffering from arthritis should stay away from eating proteins that are cooked for longer periods of time and stick to eating fresh foods or meats cooked for shorter amounts of time, which would be less than 2 hours. Due to the lack of research and knowledge of glutamate concentrations within foods, many people with arthritis are unaware of how eating foods with high amounts of glutamate can cause excessive inflammation. The results of this experiment may help to educate people about how the concentration of glutamate in proteins will increase over long periods of time cooked. And patients like my mom with arthritis will be able to stay away or understand how cooking the protein can change the concentrations of glutamate within them. And some challenges I faced while conducting my experiment were flaws in my method. I think we changed our method around 5 times, but each time we changed it, we learned from our mistakes and corrected them and fixed them to the method we have now. Some advice I would give to future students taking independent research would be to persevere through challenges and really embrace them and try and find something or a topic that you really like or really passionate about, because that's what motivates me to do my project. So before I close, I want to say thank you to my mom for being my mentor. And I want to say thank you to Mrs. Kobayashi, Dr. Chan, and Mr. Hill for helping me and supporting me through my challenges with my project. And I also want to say thank you for security for opening up the wet lab. And yeah, thank you.